6 in Necrotic World, Season 6, Space, Episode 124, Life of a Bigger Star. Welcome, strangers. Oh wait, guys, I forgot to tell you the beginnings of all stars. So I guess I'd have to tell you that then. And tell you the dramatic ending of a bigger than the sun-sized star. Once upon a star. That's funny. First stage is starburst. The stars are stellar nebulae. Nebulae? Is that plural of nebula? Well, I'm gonna... And then they become protostars. Then they reach their second adulthood stage. This main sequence stage is where we differentiate them into similar to our sun-sized stars and bigger than sun stars, so massive stars. So sun stars, similar size to sun stars, similar size to sun stars. Oh, alliteration, tricky. And bigger than sun stars. The sun-level stars proceed into star death as a red giant, then a planetary nebula, then a white dwarf, then a black dwarf. The megastars, like as in bigger than sun level, proceed into star death as red supergiants, and then a burst of supernova, and then either a neutron star or a black dwarf. The mass of star determines the lifestyle, with main sequence stars fusing hydrogen and helium. Thermal expansion effectively is balancing the gravitational pressures so that the main sequence star can vibe at a stable rate, giving off light stably. Not sure that's a word, but stable with a Y. A stellar nebula is a dust cloud that is mainly hydrogen and helium particulates. Which, with the collapse of the back of gravity, leads to temperature and pressure increase. Protostar is like the prototype, similar to a star-looking blob, with fusion not yet having begun. Planetary nebula of sun-like stars is created after fusion stops and it sheds the outer layers. A beyond a sun-like star would have a bang into a supernova, which you cannot hear as well. Space has no particles, as it is a vacuum, so sound cannot travel. And so you cannot hear anyone scream. No one can hear you scream. Supernova is when the core collapses as fusion stops, then it explodes. White dwarf is when the hot core remains, but over time, as it cools, it becomes dull into a black dwarf. Black dwarfs are not believed to be in existence yet, as the universe isn't that old apparently. But in theory, we ought to be able to see them in trillions of years. So, not our generation for sure. I doubt humanity is still living then, at least not in the same form as in now. We might be half machines or something, or maybe make our biological matter eradicated and download ourselves into some kind of like AI platform that cares for itself, like the Amazing Digital Circus or something. I mean, nah, science fiction, oh well. For sure I'd be dead by then, and most likely you too. I'd be surprised if any entity would want to read this trillions of years down the line. I mean, that would be some intellectual descendant species if they want to read this. It would be surprising for sure. A neutron star is when, after that core collapses, the protons and electrons are bashed together to form neutrons and radiate some nifty EM waves. You know, your electromagnetic waves? Yeah. Light cannot escape a black hole as it is extremely dense. So I have a small plush duck as in D-U-C-K, that a friend gave me for my birthday last year. It's called Quark. Quark. More about quarks will come in the nuclear physics topic. It's pretty exciting stuff. You know the Ada positron ring? That has always fascinated me, along with that recent paper on time crystals with their spatio-temporal symmetry. If you or anyone else likes reading physics papers, GUOS, GUOs, and Smalyuk's, sorry, I cannot pronounce names, SMALYUKH, their papers are particularly interesting on the topic of cryogenics. See you next time at Physics in Necrotic World. This is your host, Rimona Christian, R out.